Look up at the night sky. On a clear night, you'll likely see a bright, round object illuminating the darkness. This is our moon, Earth's only natural satellite and a constant presence in our lives. For millennia, humans have gazed upon this celestial body with a mixture of awe and curiosity. Its gentle light has guided travelers, inspired poets, and sparked countless myths and legends across cultures. But the moon is far more than just a pretty face in the night sky. The moon plays a crucial role in shaping our planet and our existence on it. Its gravitational pull governs the tides, dictating the rhythm of our oceans. It stabilizes Earth's axial tilt, ensuring the regular cycle of seasons that sustain life. The moon's presence has even influenced the evolution of life itself. Without our celestial companion, Earth would be a very different place. In this exploration, we embark on a journey to uncover the secrets of Earth's cosmic dance partner. We'll delve into the moon's violent birth, its powerful influence on our planet, and its enduring significance for humanity. Join us as we unravel the story of the moon, a tale written in the stars and etched into the very fabric of our world. From ancient myths to modern scientific discoveries, the moon has always captivated our imagination. Prepare to see this familiar celestial object in a new light, as we uncover the hidden connections between Earth and its steadfast companion. The moon's story is a testament to the interconnectedness of the cosmos and the profound influence celestial bodies have on one another.
Though silent and seemingly still, the moon exerts a powerful influence on our planet, shaping the very fabric of our existence in ways that are both subtle and profound. Acting as a silent guardian over Earth, its presence is a constant, a celestial companion that has been with us since the dawn of time. Its presence has shaped Earth's history from the very beginning and continues to influence our lives in countless ways. From the ancient civilizations that worshipped it as a deity to the modern scientists who study its every phase, the moon has always been a source of wonder and inspiration. One of the most obvious examples of this influence is the tides. The rhythmic rise and fall of the ocean's waters, driven by the moon's gravitational pull, is a phenomenon that has fascinated humans for millennia. The moon's gravitational pull creates a bulge of water on the side of Earth facing the moon, resulting in high tide. This gravitational dance between the Earth and the moon is a delicate balance that affects not just the oceans, but the very land we live on. As the Earth rotates, this bulge follows the moon's position in the sky, creating 2 high tides and 2 low tides each day. This predictable pattern is essential for the health of our coastal ecosystems, providing a rhythm that many forms of life depend on. This rhythmic ebb and flow of the tides are essential for many coastal ecosystems, providing a vital link between the ocean and the land. Tidal pools, for example, are teeming with life, each organism perfectly adapted to the changing environment. The moon's influence extends far beyond the tides, however. Its gravitational pull also plays a crucial role in stabilizing Earth's axial tilt, which is responsible for the changing seasons. Its gravity also stabilizes Earth's axial tilt, which is responsible for the seasons. Without the moon, our planet's tilt would be much more erratic, leading to extreme and unpredictable climate changes that could make life as we know it impossible. Without the moon, Earth's tilt would be much more erratic, leading to extreme and unpredictable climate changes. This stability has been crucial for the development and evolution of life on Earth, providing a consistent environment in which life can thrive. The stability provided by the moon has been crucial for the development and evolution of life on Earth. From the earliest single-celled organisms to the complex ecosystems we see today, the moon has played a vital role in creating the conditions necessary for life to flourish. Its influence can be seen in the very fabric of our planet, from the length of our days to the delicate balance of our ecosystems. The moon's gravitational pull slows down Earth's rotation, gradually lengthening our days over millions of years. The moon's role as a silent guardian is a testament to the interconnectedness of our solar system. It reminds us that even celestial bodies that seem distant and unchanging can have a profound impact on our lives, shaping the world in ways we are only beginning to understand. It is a reminder that even celestial bodies that seem distant and unchanging can have a profound impact on our lives. The moon's influence is a constant, a silent force that shapes our world in ways both seen and unseen. As we continue to explore the moon and unravel its mysteries, we gain a deeper appreciation for the delicate balance of forces that make life on Earth possible. Each new discovery brings us closer to understanding the intricate dance of celestial bodies that has shaped our world for billions of years.
The reach of the moon's influence extends far beyond our immediate awareness. Its gravitational pull subtly affects the Earth's rotation, gradually slowing it down over time. This effect, though seemingly imperceptible, has resulted in our days becoming longer, over millions of years. In the distant past, Earth's rotation was much faster, with days lasting only a few hours. The moon's gravitational drag has acted as a brake, gradually slowing down Earth's spin and lengthening our days to the familiar 24 hours we experience now. This slowing effect, though gradual, has had a profound impact on the evolution of life on Earth. Organisms have had to adapt to the changing cycles of light and darkness, leading to the development of circadian rhythms and a wide range of biological processes synchronized with the Earth's rotation. Furthermore, the moon's influence can be felt in the very rocks beneath our feet. The same gravitational forces that drive the tides also create subtle stresses and strains within the Earth's crust. While these effects are less noticeable than the ocean tides, they contribute to the long-term geological processes that shape our planet's surface. The moon's reach extends even further, influencing the behavior of animals. Many marine creatures, for example, rely on the moon's light for navigation and reproduction. The timing of their migrations, spawning events, and other behaviors is often synchronized with the lunar cycle. This intricate dance between the moon and Earth's creatures is a testament to the profound and often unseen connections that exist within our natural world. The moon's origin story is one of cosmic violence and creation, a tale etched in the very fabric of our solar system. Unlike the sun, which formed from the gravitational collapse of a giant cloud of gas and dust, the moon's birth was far more dramatic. Scientists believe that the moon was born from the debris of a cataclysmic collision between the early Earth and a Mars-sized object billions of years ago. This event, known as the giant impact hypothesis, is the leading explanation for the moon's existence and has revolutionized our understanding of the early solar system. Imagine a time when our solar system was a chaotic and turbulent place, filled with young planets and planetesimals still finding their place in the cosmic dance. Collisions were commonplace, shaping and reshaping the planets we know today. It was during this tumultuous period, roughly 4.5 billion years ago, that a Mars-sized object, often referred to as Theia, collided with the young Earth at a staggering speed. The impact was so powerful that it would have melted and vaporized vast amounts of both bodies, spewing molten rock and debris into space. The energy released in this collision was unimaginable, briefly turning the Earth into a fiery inferno. From this cataclysm, our moon was born. This event, though violent and destructive, ultimately led to the creation of one of the most important celestial bodies in our sky. The giant impact hypothesis provides a compelling explanation for many of the moon's unique characteristics, from its composition to its orbit around Earth. The giant impact hypothesis, first proposed in the 1970s, has become the most widely accepted theory for the moon's formation. It elegantly explains several key observations about the moon that other theories struggle to account for. One of the most compelling pieces of evidence supporting the giant impact hypothesis is the moon's composition. Lunar samples brought back by the Apollo missions have revealed that the moon's composition is remarkably similar to Earth's mantle, the layer beneath our planet's crust. This similarity suggests that the moon formed from material that originated from Earth. Furthermore, the moon has a relatively small iron core compared to Earth. This observation is consistent with the giant impact hypothesis, which suggests that the impact would have primarily ejected material from Earth's mantle and crust, leaving the iron-rich core largely intact. Another piece of evidence supporting the giant impact hypothesis is the moon's orbit. Unlike most other moons in our solar system, which orbit their planets around their equators, the moon's orbit is tilted relative to Earth's equatorial plane. This tilted orbit, along with the moon's relatively large size compared to Earth, is difficult to explain with other moon formation theories. The giant impact hypothesis provides a plausible explanation for this unusual orbit, proposing that the impact occurred at an angle that imparted a significant amount of angular momentum to the debris disk, ultimately shaping the Moon's final orbit. To create a Moon as large and as compositionally similar to Earth as ours, the impactor involved in the giant impact hypothesis must have been substantial. Scientists estimate that Theia, the hypothetical Mars-sized object, was roughly the size of Mars itself, or about 1/10 the mass of Earth. This makes the giant impact a truly cataclysmic event, unlike anything humanity has ever witnessed. The impact would have released an unimaginable amount of energy, equivalent to millions of nuclear bombs detonating simultaneously. The force of the impact would have been so great that it would have melted and vaporized the outer layers of both Earth and Theia, creating a massive cloud of superheated vaporized rock and molten debris. This debris cloud, consisting of material from both Earth and Theia, would have been incredibly hot and moving at extremely high speeds. The cloud would have expanded outwards, forming a ring of debris around the battered Earth. Over time, this ring of debris would coalesce under its own gravity, gradually clumping together to form larger and larger objects. Within this chaotic and energetic environment, the seeds of our Moon were sown. The giant impact hypothesis paints a picture of a violent and transformative event, but one that ultimately led to the creation of one of the most important celestial bodies in our sky. Following the cataclysmic impact, the cloud of debris surrounding the proto-Earth was a scene of intense activity. Gravity began to exert its pull on the scattered particles of molten rock and vaporized material. As these particles collided and stuck together, they started to form larger clumps, gradually increasing in size and mass. This process, known as accretion, is the same fundamental mechanism that led to the formation of planets in the early solar system. The debris disk surrounding Earth was incredibly hot, reaching temperatures exceeding thousands of degrees Celsius. At these temperatures, rock was molten, allowing it to flow and deform easily. As the clumps of debris grew larger, their gravitational pull increased, attracting even more material from the surrounding disk. This runaway process of accretion led to the formation of moonlets, smaller precursors to the Moon, within the debris disk. These moonlets continued to collide and merge with one another, gradually coalescing into larger and larger objects. The process of accretion and moonlet formation likely occurred over a relatively short period, perhaps only a few thousand years. As the Moon grew in size, its gravitational influence on the surrounding debris increased, further accelerating the accretion process. Finally, after millions of years of collisions and mergers, the Moon reached its current size and mass, becoming the celestial companion we know today. Though the giant impact hypothesis occurred billions of years ago, it has left behind subtle clues that scientists can use to piece together the Moon's violent birth. One line of evidence comes from studying the composition of lunar rocks. Analysis of these rocks reveals that they contain a lower abundance of volatile elements, such as water and potassium, compared to Earth rocks. This difference in volatile content supports the giant impact hypothesis, as the intense heat generated during the impact would have vaporized and driven off these volatile elements, leaving behind a Moon depleted in these materials. Another piece of evidence comes from studying the isotopes of certain elements in lunar and Earth rocks. Isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. The ratio of different isotopes can provide insights into the origin and history of materials. Scientists have found that the isotopic ratios of certain elements, such as oxygen, are remarkably similar in lunar and Earth rocks. This similarity suggests that the Moon and Earth formed from the same reservoir of material, further supporting the idea that the Moon originated from Earth's outer layers.
In the vast expanse of our solar system, the Earth-Moon relationship stands out as a celestial oddity. Unlike the myriad of other moons that orbit the planets in our solar system, our Moon holds a special place in the cosmic dance. It is not just another satellite, it is a key player in the story of Earth, influencing everything from our tides to the very tilt of our planet's axis. While many planets boast multiple moons, often small and irregularly shaped, Our moon is a solitary giant, a celestial companion that dwarfs most others in relative size. Jupiter, for instance, has over 79 moons, but none of them come close to the size of our moon when compared to their host planet. This makes our moon not just unique, but also a subject of great interest and study. This unique characteristic is no mere cosmic coincidence. It speaks to the dramatic events that birthed our lunar companion and hints at the profound influence it would exert on our planet. The prevailing theory, known as the giant impact hypothesis, suggests that a Mars-sized body collided with the early Earth, ejecting a significant amount of debris into orbit. This debris eventually coalesced to form the Moon, a process that was both violent and transformative. The Moon's diameter is roughly 1/4 that of Earth, a ratio unmatched by any other planet-Moon system in our solar system. This significant size difference is not just a trivial fact. It has profound implications for the gravitational interactions between the two bodies. The Moon's gravitational pull is strong enough to affect the Earth's oceans, creating the tides that we experience daily. This significant size difference, coupled with the Moon's close proximity to Earth, is the foundation of its powerful gravitational influence, shaping our planet in ways both dramatic and subtle. The Moon's gravitational pull not only affects the tides, but also stabilizes the Earth's axial tilt. Without the Moon, our planet's tilt could vary wildly, leading to extreme changes in climate and possibly making Earth a much less hospitable place for life. To understand the full extent of the Moon's impact, we must first appreciate the sheer scale of this celestial partnership. The Moon is about 384,400 kilometers away from Earth, a distance that seems vast but is relatively close in astronomical terms. This proximity allows the Moon to exert a significant gravitational force on our planet, influencing everything from ocean tides to the length of our days. Imagine shrinking the Earth down to the size of a basketball. This analogy helps us grasp the relative sizes and distances involved in the Earth-Moon system. The basketball represents Earth, a familiar object that we can easily visualize and hold in our hands. On this scale, the Moon would be about the size of a tennis ball, orbiting at a distance of roughly 24 feet. This visualization highlights the Moon's substantial size relative to Earth and underscores its close proximity, a combination that sets the stage for a cosmic dance of gravitational forces that have shaped our planet for billions of years. The tennis ball, though much smaller than the basketball, is still significant in size, emphasizing the Moon's role in the Earth-Moon system. This visualization highlights the Moon's substantial size relative to Earth and underscores its close proximity, a combination that sets the stage for a cosmic dance of gravitational forces that have shaped our planet for billions of years. The Moon's orbit around Earth is not a perfect circle, but an ellipse, meaning that the distance between the two bodies varies slightly over time. This elliptical orbit contributes to the complex gravitational interactions that influence our planet, from the rhythmic ebb and flow of the tides to the very stability of our planet's rotation. The Moon's size and proximity are the driving forces behind its profound influence on Earth. The tides caused by the gravitational pull of the Moon play a crucial role in the Earth's ecosystems, affecting everything from the behavior of marine life to the patterns of coastal erosion. As we delve deeper into this celestial partnership, we'll uncover the myriad ways in which this seemingly distant object shapes our world and our lives. The Moon's influence extends beyond the physical. It has also played a significant role in human culture and mythology. From ancient civilizations that worship the Moon as a deity to modern scientific endeavors that seek to understand its mysteries, the Moon has always been a source of fascination and inspiration. Join us as we explore the many facets of this celestial oddity and its profound impact on our planet.
The Moon's size, while dwarfed by the Sun's immensity, is substantial enough to make it a dominant gravitational force in Earth's vicinity. With a diameter of about 3,474 kilometers, the Moon is the fifth largest moon in our solar system. While its mass is only about 1/81st that of Earth, this significant mass, concentrated in a relatively small volume, gives the Moon a gravitational pull strong enough to influence our planet in remarkable ways. To put the Moon's mass into perspective, consider that it's greater than the combined mass of all the other moons in our solar system. This substantial mass, coupled with its close proximity to Earth, creates a gravitational tug-of-war that has shaped our planet's history and continues to influence its present. The Moon's gravity is most evident in the ocean tides, but it extends far beyond our planet's watery depths. This invisible force subtly affects Earth's rotation, stabilizing its axis and influencing the long-term evolution of our planet's climate and environment. The Moon's size and mass are not merely astronomical statistics, they are the fundamental parameters that dictate its role as Earth's cosmic dance partner. As we explore the intricacies of this celestial relationship, we'll see how the Moon's size and mass have shaped Earth's history, from its earliest days as a molten planet to its present-day environment, teeming with life. One of the most striking consequences of the Moon's size and proximity is a phenomenon known as tidal locking. Over billions of years, the gravitational interaction between Earth and the Moon has synchronized their rotations, resulting in the Moon always showing the same face toward Earth. This seemingly simple phenomenon has far-reaching implications for both celestial bodies. Tidal locking occurs because the gravitational forces between two orbiting bodies are not uniform. The side of the Moon facing Earth experiences a slightly stronger gravitational pull than the side facing away. Over time, this uneven pull has slowed down the Moon's rotation until it matched its orbital period, resulting in the same side always facing Earth. This synchronization has profound effects on the Moon's environment. Without the moderating influence of a day-night cycle, the temperature difference between the Moon's near and far sides is extreme, ranging from scorching heat to frigid cold. This extreme temperature variation has shaped the Moon's surface, creating a stark contrast between the relatively smooth dark Maria on the near side and the heavily cratered, bright highlands on the far side. Tidal locking also has subtle but significant effects on Earth. The same gravitational forces that lock the Moon's rotation also act as a brake on Earth's spin, gradually slowing down our planet's rotation over time. This effect, though seemingly imperceptible, has resulted in our days becoming longer over millions of years, influencing the evolution of life and the very rhythm of our planet. The Earth-Moon system exists in a delicate balance, a celestial dance governed by the laws of gravity. The Moon's size and proximity are crucial factors in maintaining this balance, influencing not only the tides but also the stability of Earth's axial tilt, the very foundation of our planet's seasons. This delicate balance is a testament to the intricate interplay of forces that shape our solar system and highlight the profound influence celestial bodies can have on one another. The Moon's gravitational pull creates a slight wobble in Earth's rotation, preventing our planet's axis from tilting too far in either direction. Without the Moon's stabilizing influence, Earth's axial tilt would be much more erratic, leading to extreme and unpredictable climate changes. Imagine a world where the poles experience prolonged periods of darkness followed by months of continuous sunlight, where seasons are extreme and unpredictable. This is the fate of planets without a large, stabilizing moon, and it's a fate that would make life as we know it impossible. The Moon's presence acts as a cosmic anchor, keeping Earth's axial tilt within a narrow range and ensuring the regular cycle of seasons that sustain life. This stabilizing influence is a testament to the profound impact a celestial companion can have on a planet's habitability. The delicate balance between Earth and the Moon is not static, it's a dynamic relationship that has evolved over billions of years and continues to change even today. As we delve deeper into this cosmic partnership, we'll explore how the Moon's orbit is slowly receding, gradually altering the dynamics of this ancient celestial dance. While the Moon may seem like a steadfast companion, eternally fixed in our sky, it's actually slowly drifting away from Earth. This gradual recession is a consequence of the same gravitational dance that governs the tides. As the Moon orbits Earth, its gravity creates bulges of water on opposite sides of our planet, resulting in the familiar high tides. These tidal bulges exert their own gravitational pull on the Moon, slightly ahead of the Moon's orbital path. This gravitational tug-of-war transfers energy from Earth's rotation to the Moon's orbit, causing the Moon to spiral slowly outward, away from Earth. the rate of the moon's recession is extremely slow, averaging about 3.8 centimeters per year, roughly the same rate as your fingernails grow. While this may seem insignificant, over billions of years, this gradual drift has had a profound impact on the Earth-Moon system. In the distant past, the moon was much closer to Earth, and its gravitational influence was even stronger. As the moon recedes, its gravitational pull weakens, resulting in a cascade of subtle but significant effects on our planet. From the length of our days to the stability of Earth's climate, the moon's receding orbit is a reminder that even seemingly unchanging celestial relationships are in a constant state of flux.
The moon's influence on Earth is perhaps most evident in the rhythmic rise and fall of the ocean tides, a phenomenon that has captivated observers for millennia. This daily dance of the waters is a direct consequence of the moon's gravitational pull, a force that stretches and compresses our planet, creating bulges of water that sweep across the globe. While we often take the tides for granted, they are a testament to the profound connection between Earth and its celestial companion. To understand the tides, we must first grasp the concept of gravity as a force that acts over distances. The moon's gravity pulls more strongly on the side of Earth facing the moon than it does on the opposite side. This difference in gravitational pull creates a stretching effect, elongating Earth slightly along the line connecting Earth and the moon. This elongation is most pronounced in Earth's oceans, where water, being fluid, responds more dramatically to the moon's gravitational tug. The water on the side of Earth facing the moon bulges outward, creating a high tide. Simultaneously, a corresponding high tide occurs on the opposite side of Earth, where the moon's gravity is weakest, and inertia causes the water to bulge outward as well. These tidal bulges, created by the moon's uneven gravitational pull, are the driving force behind the tides, setting in motion a rhythmic cycle of high and low water levels that shapes coastal ecosystems and influences human activities around the globe. As Earth rotates on its axis, the tidal bulges created by the moon's gravity remain relatively fixed in their position relative to the moon. This means that as Earth spins, different points on its surface rotate into and out of these bulges, experiencing high tide when they pass through a bulge and low tide when they are farthest from a bulge. Imagine yourself standing on a beach, watching the tide come in. As Earth rotates, your location is slowly carried towards the tidal bulge facing the moon. The water level rises, gradually engulfing the shore until it reaches its highest point, marking high tide. As Earth continues to rotate, your location moves past the tidal bulge and begins to approach the point farthest from the moon. The water level gradually recedes, revealing more and more of the beach, until it reaches its lowest point, marking low tide. This cycle of rising and falling tides repeats approximately every 12 hours and 25 minutes, creating the rhythmic ebb and flow of the ocean that shapes coastal environments. The dance of the tides is a constant reminder of the moon's invisible influence, a gravitational tug-of-war that governs the movement of trillions of tons of water across our planet's surface. The timing of high and low tides is not random. It follows a predictable cycle dictated by the moon's position in the sky. As Earth rotates, the moon appears to move across the sky, completing one full circuit every 24 hours and 50 minutes. This lunar cycle is slightly longer than Earth's rotation period, which is why high tides occur approximately every 12 hours and 25 minutes, rather than every 12 hours. The height difference between high and low tide, known as the tidal range, also varies depending on the moon's phase and its position relative to the sun. During a new moon or full moon, when the sun, Earth, and moon are aligned, the gravitational forces of the sun and moon combine to produce higher than average high tides and lower than average low tides. These tides, known as spring tides, are characterized by a greater tidal range. Conversely, during the first and third quarter moons, when the sun, Earth, and moon form a right angle, the sun's gravity partially counteracts the moon's gravity, resulting in lower than average high tides and higher than average low tides. These tides, known as neap tides, are characterized by a smaller tidal range. The rhythmic cycle of high and low tides, modulated by the moon's phases and the sun's influence, creates a dynamic environment along coastlines, influencing the distribution of marine life, shaping coastal erosion patterns, and even impacting human activities like navigation and fishing. The tidal bulges that create the tides are not static mounds of water. They are dynamic features that constantly shift and move in response to the moon's gravitational pull and Earth's rotation. As Earth spins, these bulges follow the moon's position in the sky, creating a wave-like motion in the oceans. This wave, however, is not a typical ocean wave that breaks on the shore. It's a much larger and more subtle phenomenon that affects the entire water column, from the surface to the ocean floor. Imagine a giant shallow bowl filled with water. If you gently tilt the bowl from side to side, you'll notice that the water level at the edges of the bowl rises and falls in response to the tilting motion. The tidal bulges are similar, except instead of a bowl, we have the ocean basins, and instead of tilting, we have the moon's gravitational pull. The moon's gravity acts like an invisible hand, gently pulling the water towards it, creating a bulge on the side of Earth facing the moon. Simultaneously, on the opposite side of Earth, inertia causes the water to bulge outward as well, as if trying to maintain its distance from the moon. These bulges, constantly shifting and moving, create the global pattern of high and low tides that we observe. The height and timing of these bulges vary depending on the shape and depth of the ocean basins, the configuration of continents, and the influence of other factors such as wind and currents. This complex interplay of forces creates a rich tapestry of tidal patterns across the globe. While the moon is the dominant force behind Earth's tides, the sun also plays a role, albeit a weaker one. The sun's gravity is much stronger than the moon's, but its greater distance from Earth means that its gravitational pull varies less across Earth's diameter. This difference in gravitational pull across Earth is what creates the tides, and since the moon is much closer, its influence on the tides is about twice as strong as the sun's. Despite its weaker influence, the sun's gravity can either amplify or diminish the moon's tidal effects, depending on their relative positions. During a new moon or full moon, when the sun, Earth, and moon are aligned, their gravitational forces combine, resulting in higher than average high tides and lower than average low tides. These extreme tides, known as spring tides, occur because the sun's gravity reinforces the moon's gravitational pull, creating a stronger tidal bulge. Conversely, during the first and third quarter moons, when the sun, Earth, and moon form a right angle, the sun's gravity partially counteracts the moon's gravity, resulting in lower than average high tides and higher than average low tides. These less extreme tides, known as nap tides, occur because the sun's gravity partially offsets the moon's gravitational pull, creating a weaker tidal bulge. The sun's influence on the tides, while subtle, adds another layer of complexity to this dynamic phenomenon.
Our planet's journey around the sun is a celestial ballet, a graceful waltz through the vastness of space. But Earth's motion is more than just a simple orbit. It's a complex dance influenced by a multitude of factors, with the moon playing a crucial role. One of the most defining features of Earth's celestial choreography is its axial tilt, a slight lean that sets our planet off kilter, creating the seasons that define our world. Unlike a spinning top that stands perfectly upright, Earth spins on its axis at an angle of approximately 23.5 degrees. This tilt, rather than being a cosmic accident, is a fundamental characteristic of our planet, influenced by the gravitational interplay between Earth, the moon, and other celestial bodies, particularly the sun. The axial tilt is not static, it undergoes subtle variations over long periods, influenced by the gravitational pull of the moon, the sun, and even the giant planets in our solar system. However, the moon's influence is paramount, acting as a stabilizing force that prevents extreme variations in Earth's tilt. Without the moon's gravitational embrace, Earth's axial tilt would be much more erratic, leading to dramatic and unpredictable climate changes that would make life as we know it impossible. The moon's presence, therefore, is not just a celestial decoration, it's a fundamental factor in shaping Earth's habitability. Imagine a world where the seasons are extreme and unpredictable, where the poles experience prolonged periods of darkness followed by months of continuous sunlight. This is the fate of planets without a large, stabilizing moon, and it's a fate that Earth narrowly avoids thanks to its celestial companion. The moon's gravitational influence acts as a cosmic anchor, preventing Earth's axial tilt from varying too widely and ensuring the relatively stable climate that has allowed life to flourish. The moon's stabilizing effect on Earth's tilt arises from the gravitational interaction between the two bodies. The moon's gravity exerts a slight pull on Earth's equatorial bulge, the slight outward bulge at Earth's equator caused by its rotation. This pull acts as a torque, trying to align Earth's axis of rotation perpendicular to the plane of the moon's orbit. However, Earth's rotation prevents its axis from completely aligning with the moon's orbital plane. Instead, Earth's axis precesses, slowly tracing out a circle in the sky over a period of about 26,000 years. This precession, combined with the moon's gravitational influence, acts to stabilize Earth's axial tilt, keeping it within a relatively narrow range. This stabilizing effect is crucial for maintaining Earth's habitable climate. Without the moon's influence, Earth's axial tilt would vary chaotically, leading to extreme variations in the distribution of sunlight and heat across the planet. The seasons, those annual cycles of change that paint our world in a kaleidoscope of colors, are a direct consequence of Earth's axial tilt. As Earth journeys around the Sun, its tilted axis ensures that different parts of the planet receive varying amounts of sunlight and heat throughout the year, creating the familiar cycle of spring, summer, autumn, and winter. During summer in the northern hemisphere, Earth's northern axis is tilted towards the Sun, resulting in longer days, shorter nights, and more direct sunlight. This increased solar radiation warms the hemisphere, leading to warmer temperatures and the lush growth of vegetation. Conversely, during winter in the northern hemisphere, Earth's northern axis is tilted away from the Sun, resulting in shorter days, longer nights, and less direct sunlight. This decreased solar radiation cools the hemisphere, leading to colder temperatures and the dormancy of many plants. The southern hemisphere experiences the opposite seasons, with summer occurring when the southern hemisphere is tilted towards the Sun, and winter occurring when it's tilted away. This reversal of seasons is a direct result of Earth's axial tilt, which ensures that when one hemisphere is tilted towards the Sun, the other is tilted away. The seasons are not merely a change in weather patterns, they are a fundamental driver of life on Earth, influencing the behavior, distribution, and evolution of organisms across the globe. The seasons are more than just a change in scenery. They are a fundamental force that shapes the rhythms of life on Earth. From the timing of plant growth and animal migrations to the reproductive cycles of countless species, life has evolved to synchronize with the ebb and flow of the seasons, a testament to the profound influence of Earth's axial tilt. Plants, being rooted in place, are exquisitely attuned to the changing seasons. They have evolved sophisticated mechanisms to sense changes in day length and temperature, triggering the growth of leaves and flowers in spring, the ripening of fruits in summer, and the shedding of leaves in autumn. Animals, too, exhibit a remarkable array of adaptations to cope with the challenges and opportunities presented by the seasons. Many species migrate long distances to find food and suitable breeding grounds as the seasons change, while others hibernate during the cold winter months, slowing their metabolism to conserve energy. Even humans, despite our technological advancements, are still influenced by the seasons. Our sleep patterns, moods, and even our immune systems are subtly affected by the changing seasons, a reminder of our deep connection to the rhythms of the natural world. The seasons, therefore, are not merely a backdrop to life on Earth. They are an integral part of the fabric of our planet, shaping the evolution, behavior, and interconnectedness of all living things. Section 5. The Moon's Receding Influence, a Long-Term Perspective. While the Moon currently plays a crucial role in stabilizing Earth's axial tilt, this cosmic partnership is not static. As we've seen, the Moon is slowly spiraling away from Earth, a consequence of the same gravitational dance that governs the tides. This gradual recession, while seemingly insignificant on a human timescale, has profound implications for the long-term future of Earth's axial tilt and the stability of our planet's climate. As the moon drifts farther away, its gravitational influence on Earth weakens. This weakening grip will gradually diminish the moon's stabilizing effect on Earth's axial tilt, making our planet more susceptible to gravitational nudges from the sun and other planets in our solar system. Over millions of years, this increased susceptibility to gravitational perturbations could cause Earth's axial tilt to vary more significantly, potentially leading to more extreme climate swings. While these changes are unlikely to happen on a human timescale, they highlight the dynamic nature of the Earth-Moon system and the profound influence even subtle cosmic shifts can have over eons. The moon's receding orbit is a reminder that our planet's climate is not static. It's a dynamic system influenced by a complex interplay of forces, both terrestrial and cosmic. Understanding these forces and their long-term effects is crucial for predicting the future of our planet and ensuring the continued habitability of our world.
The moon's influence extends far beyond its most obvious effects on Earth, shaping our planet and its inhabitants in subtle but profound ways. While the tides and the stability of Earth's axial tilt are perhaps the most well-known examples of the moon's influence, our celestial companion plays a multifaceted role in shaping the rhythms of life, influencing geological processes and even inspiring human endeavors. From the faint glow of moonlight that guides nocturnal creatures to the subtle stresses and strains the moon's gravity exerts on Earth's crust, the moon's influence is pervasive, touching every aspect of our planet's environment and its inhabitants. To truly appreciate the moon's significance, we must look beyond its most obvious effects and delve into the hidden connections that bind Earth and its celestial companion. In this exploration of the moon's less heralded influences, we'll uncover the surprising ways in which this celestial object shapes our world, from the behavior of animals to the very structure of our planet. The moon's story is a testament to the interconnectedness of the cosmos, where even seemingly distant objects can exert a profound influence on our lives. As we continue to unravel the mysteries of the moon, we gain a deeper appreciation for the delicate balance of forces that make Earth such a unique and habitable planet. And we discover that our celestial companion is more than just a silent orb in the sky. It's an integral part of what makes our world so special.
The moon's gentle glow, a pale reflection of the sun's brilliance, may seem insignificant compared to the sun's blinding light. However, this celestial body, orbiting our planet with a serene grace, holds a profound influence over the natural world. Its light, though faint, is a beacon in the night, guiding and shaping the lives of countless organisms. The moon's phases, from the new moon to the full moon, create a rhythmic dance that has been a constant presence in the night sky for eons. Yet, this faint lunar illumination plays a crucial role in shaping the rhythms of life on Earth, influencing the behavior, navigation, and even the reproductive cycles of countless organisms. The moon's gravitational pull not only affects the tides, but also subtly influences the biological clocks of many species. This synchronization with the lunar cycle is a testament to the intricate connections between celestial movements and terrestrial life. For nocturnal creatures, the moon's light is a lifeline, illuminating the darkness and guiding their movements. These animals have evolved to take advantage of the moonlit nights, using the light to hunt, forage, and navigate. The moonlight provides a delicate balance, offering enough illumination to see without being too bright to expose them to predators. Owls, with their exceptional night vision, rely on moonlight to hunt, their silent wings carrying them through the darkness in pursuit of prey. The moonlight enhances their already keen senses, allowing them to spot the slightest movement of a mouse or the flutter of a moth. This symbiotic relationship between the owl and the moon is a perfect example of nature's harmony. Bats, too, depend on the moon's glow to navigate and locate insects, their echolocation abilities enhanced by the presence of even faint light. The moonlight helps them to avoid obstacles and find their way back to their roosts. Insects, drawn to the moonlight, become easy prey for these agile hunters. This delicate interplay between predator and prey is a dance choreographed by the moon, In the depths of the ocean, where sunlight fades into perpetual twilight, the moon's cycle dictates the movements of marine life. The gravitational pull of the moon creates tides that influence the feeding and breeding patterns of many marine species. The moonlight penetrating the water's surface provides a signal for these creatures to rise from the depths, creating a nightly migration that is one of the largest movements of biomass on the planet. Coral reefs, those vibrant underwater cities, synchronize their reproductive cycles with the lunar phases, releasing millions of eggs and sperm into the water during specific moonlit nights. This mass spawning event, known as coral spawning, is a spectacular sight, with the water filled with tiny glowing particles. The timing of this event is crucial, as it ensures that the eggs and sperm meet in the water, increasing the chances of fertilization. This mass spawning event, timed to coincide with favorable tidal currents and increased prey availability, highlights the profound influence of the moon's cycle on marine ecosystems. The moon's gravitational pull creates currents that carry the fertilized eggs to new locations, spreading the coral's genetic material across the reef. This process ensures the continued diversity and resilience of coral populations. Even on land, the moon's influence is felt in the behavior of animals. Deer, for example, are more active during the full moon, using the increased light to forage and move safely through their habitats. Wolves, too, are known to howl more frequently during the full moon, using the light to communicate and coordinate their pack's movements. The moonlight creates a unique environment that shapes the behavior of these terrestrial animals. Some species of frogs and toads synchronize their breeding cycles with the lunar phases, congregating in large numbers under the moonlit sky to mate. The moonlight provides a signal for these amphibians to gather, creating a chorus of calls that can be heard for miles. This lunar-driven synchronization increases their chances of reproductive success, ensuring the continuation of their species. This lunar-driven synchronization increases their chances of reproductive success, ensuring the continuation of their species. The moonlight provides a safe environment for these amphibians to mate, with the light helping them to find each other and avoid predators. The moon's influence on their breeding cycles is a crucial factor in their survival. The moon's gentle light, therefore, is not merely a celestial decoration. It's a vital cue that governs the rhythms of life, influencing the behavior and survival of countless organisms across our planet. From the depths of the ocean to the highest mountains, the moon's influence is felt in every corner of the natural world. Its light, though faint, is a guiding force that shapes the lives of all who dwell under its glow. The moon, with its serene presence, continues to be a source of wonder and inspiration, reminding us of the delicate balance that sustains life on Earth.
The pull on land lunar tides in solid Earth. While we often associate tides with the rhythmic rise and fall of the ocean, the moon's gravitational pull also affects the solid Earth, creating subtle but measurable tides in the land itself. Just as the moon's gravity stretches and compresses the oceans, it also exerts a similar, albeit weaker, effect on Earth's crust and mantle. These solid Earth tides, also known as terrestrial tides, are much smaller in magnitude than ocean tides, typically measuring only a few centimeters in vertical displacement. However, despite their diminutive size, these tides can have a significant impact on geological processes, particularly in areas with active tectonic activity. The stresses and strains induced by solid Earth tides can trigger earthquakes, albeit usually small ones, by altering the balance of forces along fault lines. These tidal stresses can also influence volcanic activity, promoting or inhibiting the rise of magma from deep within Earth's interior. In addition to their effects on earthquakes and volcanoes, solid Earth tides also play a role in shaping Earth's rotation. The gravitational interaction between the moon and Earth's tidal bulges, both in the oceans and in the solid Earth, gradually slows down Earth's rotation, lengthening our days by a tiny fraction of a second each century. This subtle but relentless effect, a consequence of the conservation of angular momentum, highlights the interconnectedness of Earth systems and the far-reaching influence of the moon's gravity. Geological whispers, shaping Earth's face. The moon's influence on Earth's geology extends far beyond the subtle tug of solid Earth tides. Over billions of years, the moon's presence has played a significant role in shaping Earth's surface, influencing the formation of continents, the erosion of mountains, and even the very composition of our planet's atmosphere. One of the most profound ways the moon has influenced Earth's geology is through its role in stabilizing Earth's axial tilt. As we've seen, the moon's gravitational influence helps to keep Earth's axial tilt relatively stable, preventing extreme variations that would have had catastrophic consequences for Earth's climate and the evolution of life. This stability has allowed for the development of distinct climate zones on Earth, from the tropics to the polar regions, fostering the diversity of life we see today. Furthermore, the moon's gravity has influenced the movement of Earth's tectonic plates, the massive slabs of rock that make up our planet's outer layer. The stresses and strains induced by the moon's gravity, along with the sun's gravity and Earth's internal heat, have contributed to the slow dance of the continents, a process known as plate tectonics. This dance has shaped Earth's surface, creating mountain ranges, ocean basins, and the very continents we inhabit. The moon's influence on Earth's geology is a testament to the interconnectedness of our planet's systems, and the profound ways in which celestial bodies can shape the worlds around them. Magnetic shielding, a lunar contribution. Earth's magnetic field, a protective bubble that shields us from harmful radiation from the sun and other cosmic sources, is essential for life as we know it. This magnetic field is generated deep within Earth's core, a molten iron dynamo powered by the planet's internal heat. While the exact mechanisms that drive Earth's magnetic field are still not fully understood, some scientists believe that the moon may play a subtle but crucial role in maintaining this protective shield. The moon's gravity, as we've seen, exerts a tidal force on Earth, stretching and compressing our planet. This tidal force, while most evident in the oceans, also affects Earth's core, creating a slight but constant stirring effect. This stirring motion, some scientists hypothesize, helps to maintain the convective currents within Earth's core, the very currents that generate our planet's magnetic field. Without the moon's gravitational nudge, Earth's core might not be as dynamic, potentially weakening the magnetic field and leaving our planet more vulnerable to harmful radiation. While the moon's contribution to Earth's magnetic field is still a topic of debate among scientists, it highlights the interconnectedness of Earth's systems and the possibility that even seemingly unrelated celestial phenomena can have a profound impact on our planet's habitability.
As we conclude our exploration of the moon's profound influence on Earth, we're left with a sense of awe and wonder at the intricate workings of the cosmos. From the violent birth of our celestial companion to its subtle but persistent shaping of our planet, the moon's story is a testament to the interconnectedness of the universe. It reminds us that even seemingly distant objects can exert a profound influence on our world, shaping the rhythms of life, influencing the very ground beneath our feet, and inspiring us to reach for the stars. The celestial tapestry that connects Earth and the moon is woven from threads of gravity, light, and time. Gravity, that invisible force that binds the cosmos, governs the moon's orbit, dictates the ebb and flow of the tides, and even influences the very structure of our planet. Light, a messenger from distant stars, reflects off the moon's surface, illuminating the darkness and guiding the movements of nocturnal creatures. Time, a relentless sculptor, has shaped the Earth-Moon system over eons, slowing our planet's rotation, pushing the moon farther away, and influencing the evolution of life itself. This intricate interplay of forces has created a world of remarkable diversity and beauty, a world where life has flourished under the watchful gaze of our celestial companion. The moon's story is a reminder that we are not isolated observers in a vast and indifferent universe. We are active participants in a cosmic dance, inextricably linked to the celestial objects that surround us.
The moon, once a mysterious orb in the night sky, has become a familiar companion, a celestial beacon that has guided humanity for millennia. From ancient myths and legends to modern scientific exploration, the moon has captivated our imagination, inspiring artists, poets, and dreamers to ponder our place in the cosmos. Its gentle glow has illuminated the darkness. Its phases have marked the passage of time, and its presence has shaped our understanding of the universe and our place within it. As we've explored the moon's influence on Earth, we've come to appreciate its crucial role in shaping our planet's environment and the very rhythms of life. Without the moon, our world would be a vastly different place, with extreme climate swings, chaotic seasons, and a much shorter day. The moon's presence has not only made Earth more habitable, it has also influenced the evolution of life itself, from the timing of coral spawning to the migratory patterns of birds. Our relationship with the moon is not merely one of passive observation. We have reached out to touch our celestial neighbor, leaving our footprints on its dusty surface and bringing back pieces of it to study. The Apollo missions, a testament to human ingenuity and our thirst for exploration, marked a turning point in our understanding of the moon, transforming it from a distant object of wonder into a world we could explore and study firsthand. The moon, therefore, is more than just a celestial object. It's a mirror reflecting our own curiosity, our desire to explore the unknown, and our deep connection to the cosmos.
As we look to the future, the moon continues to beckon, promising new discoveries and opportunities for exploration. No longer content with simply gazing at our celestial companion, we are on the cusp of a new era of lunar exploration, one that aims to establish a sustained human presence on the moon and unlock its secrets. This renewed interest in the moons is driven by a confluence of factors, including scientific curiosity, the search for resources, and the desire to push the boundaries of human ingenuity. Scientists are eager to return to the moon to conduct more detailed studies of its geology, its history, and its potential for harboring resources, such as water ice, that could be used to support future missions. The moon also offers a unique environment for conducting astronomical observations, free from the distorting effects of Earth's atmosphere. The moon's proximity to Earth makes it an ideal location for testing new technologies and developing the capabilities needed for human missions to Mars and beyond. The challenges of living and working on the moon, from dealing with radiation to growing food in a harsh environment, will provide invaluable lessons for future space exploration. The moon, once a symbol of distant wonder, is now becoming a stepping stone, a proving ground for our ambitions to explore the solar system and beyond. As we venture back to our celestial companion, we carry with us the knowledge gained from past missions, the dreams of generations, and the unwavering spirit of exploration that defines humanity's quest to understand our place in the cosmos. The moon's story is ultimately a story about our own planet, a testament to the profound ways in which celestial bodies can shape and influence one another. From the stability of our planet's axial tilt to the rhythmic ebb and flow of the tides, the moon's presence has been a constant throughout Earth's history, shaping our planet's environment, influencing the evolution of life, and inspiring our dreams of exploration. As we continue to unravel the mysteries of the moon, we gain a deeper appreciation for the delicate balance of forces that make Earth such a unique and habitable planet. The moon's story reminds us that our planet is not an isolated island in the vastness of space. It is a dynamic and interconnected part of a larger cosmic system, influenced by the gravitational pull of distant objects and the flow of energy from the sun. The moon's enduring embrace is a symbol of the interconnectedness of the cosmos, a reminder that we are all part of a grand cosmic dance, forever linked to the celestial objects that surround us. As we look up at the moon in the night sky, we are reminded of our place in the universe, our connection to the past, and the infinite possibilities that lie ahead. The moon's story is just one chapter in the grand narrative of the universe, a story that continues to unfold with each new discovery. As we explore the cosmos, from the planets and moons in our solar system to the distant galaxies billions of light years away, we are constantly reminded of the vastness, the beauty, and the mystery of the universe we inhabit. The moon, our closest celestial neighbor, has served as a stepping stone, a celestial guidepost that has helped us to understand our place in the cosmos. Its exploration has taught us valuable lessons about the challenges and opportunities of space travel, about the importance of scientific inquiry, and about the interconnectedness of all things. As we venture farther into space, the Moon will continue to hold a special place in our hearts, a reminder of our first tentative steps beyond Earth, and a symbol of the boundless possibilities that await us. The universe is a place of wonder, filled with mysteries yet to be solved, discoveries yet to be made, and stories yet to be told. The Moon's story is just the beginning, an invitation to explore, to learn, and to never stop marveling at the beauty and the grandeur of the cosmos.